Hello, welcome to another video. What do sprinters eat before they race? Nothing. They fast. All right, that was a good one. Ha ha ha. Hi hee hee. Ha ha. Okay. Uh, New topic. Intro to calculus. Probably one of the best subjects. I'm going to keep it to the basics here, but all you really need to know about calculus is we're talking about the mathematics of change. Okay, so it's no longer static math, it's no longer algebra. We're kind of flipping over into this thing called calculus where we calculate how things change. And so the first big thing that we kind of look at is we look at this idea of differentiation. Okay, it's a process of finding the rate of change, or sometimes we call it the gradient function. It's this kind of thing that helps us to find the rate of change. Right, there's going to be three main methods that we're going to use to figure out the differentiation or to find the gradient function. The first one is graphically. We'll do that one today. And then there's also algebraically, which is kind of the easier one. And then there's a method using limits, which we call first principles, which we'll take a look at another lesson. So the first thing we need to know is there's a big important thing. I don't know how to put it, but essentially tangents are an important part of this whole topic. Okay, so we're going to do this differentiation by graphing, and there's just a couple things that I want you to know. First, we're going to talk about notation. Okay, so if I'm saying that fx, I know my x's sometimes look like n's, but just deal with me. The fx is your kind of function that you're given. If I write f dash x, that's the derivative, or that's the gradient function. It's been derived. And if we do f double dash x, it means that it's the derivative of the derivative, or the derivative of the gradient function, whichever one you prefer to use. The reason that I'm giving you the different words is because they'll talk about it with different words, and you'll kind of need to know that they mean the same thing. Okay, before we can get too far on, we need to talk about tangents, chords, and secants. I'll be completely honest, tangents is probably the one that you need to be the most familiar with. A chord and a secant less so. Let's kind of label these. This one here is a chord. So that means it goes from one point of a curve to the other, but it's just a little section in there. If it cuts all the way through, that's what we call a secant. And this is the most important one here. It's the tangent. Okay, so it touches, the important part here is that a tangent, it touches at exactly one point. Okay, now we'll talk about how it might not always be the case, but in most cases, the tangent means it touches the curve at one point and one point only. And you can see it's that giant green dot that I've got there. Okay, now the reason that the tangent is important is it finds what we call the instantaneous rate of change. It just means that it finds the particular rate of change at that particular point. And I wrote, yeah, same thing, touches the curve at one point. Okay, now that we have a bit of an idea of what a tangent is, we're going to take a look at this and just see how we go. We're going to consider this function that I've drawn. I've kind of made it up. It doesn't have to be a real function. It just, for now, we've got a curve. Okay, don't know what the equation of that curve is. I'm sure I can figure it out, but for now, let's just consider that that's a curve. We want to draw the tangents at three different locations. We want to draw the tangent at x equals -2, x equals to 1, and x equals to 3. So let's do that, and I'll do them in red. So if I'm saying x equals to -2, that's kind of down here. So I'm going to kind of almost go up until I find my actual graph. And the tangent at that point means I'm going to try my best here. I already know. Oh, I'm going to try a bit better. You want to draw a line that just goes and touches. I'm not going to lie, I don't think I'm going to get any better than that. You want to draw a line that just goes through that point and touches that curve at one point. If I'm talking about x equals to 1, I'm going to do the same thing. I'm going to pick 1, and it's right there. Now, because of the nature of this, the only way I can draw a line where it only cuts once is it actually has to be, for this one, a straight horizontal line. Okay, we'll talk about the significance of that as we go on. And if I go x equals to 3, again, I'll kind of find x equals to 3, remembering if you're a little bit lost, remember that you're always dealing with x and y. X is always your horizontal kind of movement. So if I look at that now, this is my point at x equals to 3. That's the function. And to draw a tangent would be something like that. Okay. Now, of course, you could probably draw them a little bit better than I have, but I hope that is enough for you guys to kind of see what they are. So that's pretty sure that's A, pretty sure that's B, pretty sure that's C. Okay, that's drawing the tangent at different points. Now, what's important to note here is at certain points, we will have, this is what we call a positive gradient. This is, if it's a horizontal line, it's not positive, it's not negative. So we actually say it's a 0 gradient. And for this one here, we're back to another positive gradient. And you can see somewhere like maybe if I went in between here, if I drew a little one there, that's got a negative gradient. Just remembering that positive always points to the top right and negative always points to the bottom left. No, top right and bottom right. Okay, so positive will shoot up towards the top right, negative will shoot towards the bottom right. Okay, that makes sense, hopefully. Now, moving on, this is probably where it gets to the slightly more important bit, understanding how to graph a derivative, a differentiated version of the graph just by eye, so doing it graphically. Okay, now what I've written here is for us to do that, we need to consider the gradient of the tangents at every point on this curve. So the way that I'm going to do this is, I'm just going to take a look. If I was to draw, I'm going to draw tiny little gradients. And it's kind of like you can see that my gradients will kind of do this. You can kind of see how it goes from, I guess, how do I put it? From negative to, look, let's talk about it this way. If I start by drawing a tangent here, that is a positive tangent, okay? So it's shooting up to the top right. So it is a positive tangent. It's going to be positive, 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 up until this point, because now it actually hits the horizontal, which means that now this is a gradient. Okay, that means the rise over run is theoretically 0. Now I'm struggling to move it. Please move. All right. So at this point here, this becomes 0. And then I start tipping over this way. So now it's actually a negative gradient up until I hit this point here, which becomes, again, flat, right? Flat gradient, which is 0. And then it shoots kind of back up. So my gradients now become positive again, all the way up until here. Okay, now I'm going to use this to help draw my derivative. So if this here is my f of x, what I'm going to do is I'm going to transcribe it below using my information. So the easiest way to do that is to use my zeros. So wherever it was 0, I'm almost going to draw like a line down here. And I know it's going to go through 0 at that point. And drawing a line down here, I'm going to draw it right underneath each other. And wherever my gradient was 0, now I'm going to be 0. And so the way that we try to draw this now is we take a look. On this left-hand side, our gradient was positive, which means on this side, I must be positive in this kind of area. And in between here and here, I'm all negative. So that means down here, I'm actually negative. And for this last one, we're back to positive on this side. So we've got positive. Okay, so we don't have to draw it perfect, but I hope that you can kind of see that our graph will actually come up like this. It's actually got to go to past the 0. It'll be negative until I hit this point here, and then it goes to positive. So you can kind of see that's horrible. It will come back up. And I'm going to see if I can try to fix it, please. Yeah. And so what happens is this now, I have successfully drawn my first derivative. Let's do it one more time and see if we can draw the second derivative. Okay, so let's take a look and do the same process that we did to the first one. So I'll note here that all the gradients of the tangents at this point here, you can kind of see they're pointing towards the bottom right. So it's actually a negative tangent. It kind of evens out until I hit this point, and I can see that that becomes a 0. And then from this side here, my tangents start becoming positive again. And so I've kind of got pluses up here. Okay, so if I was to draw this now below, do the same thing, I'd find where the zero was, and it's kind of like right on the axes. So that 0 would go right on the 0. And then it's saying here that on the left-hand side, it should be negative, while on this side here, I should be positive. So for this one, it actually becomes a nice, let's do it in blue. I just need to be negative on the left-hand side, positive on the right-hand side, and actually I can draw that with a nice straight line. Okay, they'll give you kind of different examples, but that's essentially what you'll be doing. That's how you would draw the derivative graphically. Hope that helps, and I'll catch you guys in the next video. See you guys later.